Welcome to The Explainer. Okay, let's dive right in and explore exactly how data is going to fundamentally reshape our world. But perhaps even more importantly, we're going to uncover the hidden rules to actually making those grand visions work. We hear a ton of buzzwords about the future, right? Well, today we're skipping the hype. We're looking at the concrete ways our biology and our urban environments are changing and what it literally takes to execute these massive data transformations successfully.
So, I want you to think about this. What does curing a rare disease actually have in common with reducing a city's traffic? On the surface, absolutely nothing. But under the hood, the answer lies in the awe-inspiring future of data science. The exact same foundational principles of gathering, cleaning, and analyzing vast streams of information are being deployed to solve both of these incredibly complex human challenges.
Section 1. Precision Medicine and Healthcare from Intuition to Evidence. All right, to start us off, let's zoom in on human biology. We are finally moving away from an era of medical guesswork and entering the age of true precision. Traditionally, medicine has operated on a kind of one-size-fits-all approach, largely based on broad intuition and general population averages. But now, we're shifting into the thrilling reality of precision medicine. By using rapid genome sequencing, scientists can pinpoint the exact mutations causing rare diseases and design bespoke drugs tailored specifically for your unique genetic makeup. It's a massive shift from intuition right to hard, personalized evidence. And honestly, the technology making this possible goes way beyond standard genetic testing. We are looking at a future where you might wear or even swallow medical sensors. No way, right? But these devices will track your vital signs 24/7, sending continuous streams of data straight to centralized monitoring units. So instead of reacting to an illness after you show symptoms, healthcare providers are going to use predictive analytics to administer treatments like life-saving antibiotics exactly when they're needed, before you even realize you're getting sick.
Section 2. The Rise of Smart Cities, Managing the Urban Future.
Okay, let's zoom way out from the microscopic human body to the sprawling metropolis, because that exact same predictive power is being applied to the cities we live in. This whole urban transformation starts with the Internet of Things, or IoT. Think of IoT as basically the central nervous system of a modern city. By linking physical devices directly to data streams, our environment can suddenly communicate. Devices share real-time information, which allows the city itself to anticipate our needs, manage its resources, and react to changing conditions instantly.
Take this Smart Santander project over in Spain, for example. They didn't just talk about a smart city, they actually built one. They installed over 12,000 connected sensors all throughout the city. And these sensors are constantly monitoring ambient light, noise, temperature, and even tracking carbon monoxide levels. They can even manage citywide parking availability by directing drivers to open spots in real time. That drastically reduces traffic and emissions. It's just a real game changer.
Now, the crucial point here is scale. Imagine the impact of Tokyo installing over 10 million smart electricity meters. 10 million. That kind of scale allows citizens and power companies to monitor and optimize energy usage in real time, completely transforming how a massive urban center distributes its resources.
And it's not just Tokyo or Spain. I absolutely love Glasgow's future city model. They took this ingenious approach to conserving energy by installing smart streetlights. But here's the catch. They aren't just on a simple timer. They use data to light the way only when someone is actually present on the street. It's elegant, it's highly efficient, and it is entirely data-driven. Now, I know what you might be thinking. If this future is so bright, why do we hear about so many tech and data projects completely crashing and burning? Well, to answer that, we have to look at this famous quote from Leo Tolstoy. Happy families are all alike. Every unhappy family is unhappy in its own way. Section 3. Why Data Projects Fail, the Anna Karenina Framework. So, Tolstoy's quote brilliantly illustrates the reality of data science. You see, a data project is exactly like one of his families. To be happy, or in this case, to actually succeed, a project must succeed in every single critical aspect. But it only takes failing in just one of those areas to bring the whole multi-million-dollar endeavor crashing down. So to avoid that unhappiness, let's look at the 5 foundational pillars required to turn those grand futuristic visions we just talked about into functioning realities. If any one of these collapses, the whole thing fails. We've got clear focus, high-quality data, the right people, validated models, and management support. Let's break them down.
Pillar 1 is focus. I really want to emphasize that without a clear, specific goal from the very get-go, even the most advanced machine learning algorithms will just wander aimlessly. You can't just throw algorithms at a wall and hope they do something useful. You absolutely must have a clearly defined problem to solve before you even touch the data.
And speaking of data, let's look at Pillar 2. There's this dangerous trap of thinking more is always better when it comes to data. Guys, that is a myth. Having massive amounts of raw data is completely useless if it's full of errors. Dirty data from poorly designed systems practically guarantees a failed project. You absolutely must have high-quality, clean data.
Moving on to Pillar 3, the right people. Now, you might think you just need a room full of coders, but a diverse team is absolutely mandatory. You need domain experts who understand the actual real-world problem, database managers, and business analysts. But crucially, you need data scientists who can communicate clearly. A brilliant model is useless if the scientists can't explain their complex findings to the non-technical colleagues who actually have to use it.
Now, Pillar 4 involves having validated models, which we'll actually touch on in a moment, but I really want to stress Pillar 5, management support. Data science is a long-term strategy, folks. It's not a one-off IT project. Without top-level executives championing the project and integrating these analytical models into daily operational workflows, the best insights will simply gather dust on a shelf.
Okay, but what if you nail all 5 pillars? You're good, right? Well, there is a hidden danger called concept drift. This happens when a predictive model becomes obsolete simply because the real-world behavior it mimics has fundamentally changed. The world isn't static. People's habits change, environments shift. And because the world constantly changes, yesterday's brilliant algorithm might be completely useless tomorrow.
Section 4, the power of iteration, the never-ending cycle. And this brings us to our final, ultimate requirement for success, the absolute necessity of constant iteration. Data science is never truly finished. This cyclical nature is perfectly captured by standard data science frameworks. The whole process loops back on itself. You start with understanding the business and the data, you prepare it, model it, evaluate it, and deploy it. But you have to continuously monitor and update those models to match those shifting real-world realities we just talked about. It is a never-ending cycle of improvement. As we dive a little deeper into the step-by-step breakdown of these phases, I want to point out a pretty fascinating reality. Within these phases, a staggering 80% of a team's time is often spent just preparing and cleaning the data in those early steps. Yeah, 80%. All of that work happens before any of the futuristic, glamorous modeling even begins. It's hard, meticulous work, but it sets the absolute foundation for success. Which brings us to our final thought. As data weaves into the very fabric of our biology and our cities, fundamentally transforming everything around us, the stakes are incredibly high. So I'll leave you with this question to consider. How will you ensure your next grand vision is built on a solid foundation of reality? Remember those 5 pillars, embrace the cycle of iteration, and you'll be well on your way. Thanks for joining me on this explainer, and keep learning.